Okay. So let me do this. Okay. Okay. So for 4 by 4, yeah? Oops, gerak pula. Okay, just leave it there. All right. So this is 4 by 4 matrix. And you see, this one is -1. Okay. So you want to make the one underneath all 0. Right? You can see my writing, right? The purple color. Okay. So you don't want to multiply the first one by -1 because then you will change the determinant. Okay. But this number is already okay because it's -1. So you just make the underneath 0. So actually, this one, R1 plus R2, and this one, 3R1 plus R3, and this one, 3R1, 2R1, 2R1 plus R4, you can do it at the same time. Yeah, Eugene, you can do it at the same time. So you will save 3 times of writing in the matrices. Okay, so I will write here. That is why I want to see your answer rather than just me giving the fastest. So for this one, I just put like this, yeah, for determinant. Okay, what you do is by matrices. So you said you do this, you do this, you do this, you do this, you do that, and all is KRI plus RJ. And then you said since this is upper triangular matrix, the determinant of the original is the same with the determinant of the last one. And you had to mention that somehow why they are equal, right? Determinant A is equal to, call this last one equal to maybe a wiggle. Yeah, okay. Actually, how I do this, you go, I don't know if you can do it, but it's annotated. Okay, so this one, determinant of A, somehow you have to put is equal to determinant. Oh, senang. Saya pakai mouse ni. And it will be easier, right? So you have to put here, Eugene, that determinant of A, the original one, is actually equal to the determinant of the A wiggle, because all your the row operation is KRI plus RJ. Yeah. So you don't change the row. But what I want to do now is to put everything in determinant. This determinant is equal. You see what's the difference? The one that you do is putting in or reducing the matrix into upper triangular. But the one I do is by just equal determinant. So this is equal. So I put row 1 plus row 2, 3 row 1 plus row 3, 2 row 1 plus row 4. Since they are all the KRI plus RJ, the determinant is equal. Otherwise, if you change, you put negative here. Yeah. So you just do this, then you add, then you multiply by 3 and add. Oops, right. Multiply by 3 and add. Multiply by 2 and add. Okay, do I get? Okay, I get this one. Yeah, the same. Right? Okay, so I skip I don't have to write the two matrices in the middle, this one. I save the time. So you can just do this at one same time. And then what happened after this? What he did is, let me see, negative 2R3 plus R2. Okay, you want to make this 1 because if you change row, you have to multiply later by negative. Yeah, but what he did is he used this to get this to be 1. Okay. If you don't want to do that and just change, this is also possible. It's not unique. Yeah, I can do like this, negative. You see this negative because I want to change row 2 with row 4. But very, very dangerous because you might not remember to write the negative. Okay, so I change the row. Yeah, but don't forget this negative. Then you can make this and this 0. Okay, let me do this first, then I explain you. Okay, so to make copy, copy negative, yeah. Okay, negative 1, 1, 1, 1. Okay, copy 0, 1, 0, 3. Negative 2, row 2 plus row 3. Negative 2, row 2 plus row 3. Negative 5, row 2 plus row 4. Negative 5, row 2 plus row 4. So I get 0, negative 2 and add. Negative 2 and add. Negative 5 and add. 0, 5. Negative 5 and add. So what you have is 1, and then you get all 0, and then there is a 7 there, but you want to make underneath 0, right? Okay. Any mistake so far? Is it okay? I still have the negative, yeah? Okay. And then I want to make this 0. So negative row 3 plus row 4. Negative 5 and add. Negative 5. And negative 5. Negative 1 and add. Negative 1 and add. Negative 13. The answer is not the same. What's wrong? So this,
your screen is too small.
oh, okay, sorry. Let me, you have to stop sharing. You know, you can move the screen sharing to the left and make my screen big. But Eugene, stop sharing. Okay. You can actually, when people share the border, you can drag and make the sharing screen small, and then you can click on mine and pin it or just spot. You can click actually pin. You can actually move the border. Okay, but anyhow, okay, this is the original. Okay, this is still the same with you, right? Okay, and then I want to change this one to be here. So -1, 1, 1, 0, 1, 0, 3, 0, 2, 5, 4, 0, 5, 9, 0. And I put negative because I have do the row, right? And then this one I copy over there, but I want to make this 0. So -2 and add. -2 and add. -2, -6 and add. I get this. And then this one, -5 and add. -5 times 0. What is this? 9. Ah, this is 9. Sendiri Pak punya tulisan tak faham. This is the problem. -5 and add, -5 is 9. Okay, sorry about that. And then -5, -15 and add, right? So I get this. Okay, now I cannot do this anymore. That's why that's a problem. Okay, how do I get this to be 0? It's a little bit tricky, right? How do I get this to be 0?
Rho times 9/5. -9/5.
So you can write -9/5 row 3 plus row 4. Is it?
Oh, yes.
It's this over this. You want to multiply over 5, but you don't want to change it to 1. So you divide by 5, but then you add the negative this. So 0, 0, -9/5 times 5, right? For this one, row 3 plus 9. So that's why you get 0. And then -9/5 times row 3 plus -50. What's the answer? 18, right? 18/5 minus 15. This one is to make
-57/5.
okay, because this is 18/5 minus 75/5. So this minus this is -57/5. So when you multiply, you don't forget the negative. So when you multiply, you get this and 5 gone, right? So 57. Negative, negative, positive, negative, negative. Okay, so that's why I actually advise you not to change the row because you might forget. Okay, because you might forget. The question is to find the determinant using property. Okay, so you cannot use the method from the cofactor expansion. Okay, because if you use cofactor expansion, from here, right, this is hard because you have to find so many, but from here you can actually, if you can use cofactor expansion, I would suggest you do one row operation one time, and then choose this column, right? And then you are down to 3 by 3, right? So if the question just find the determinant, somehow you cannot just get the matrix put in calculator, get the answer right away, right? You have to show the calculation. So what you can do is you can take the first one, do one row operation, do the column, and then you do -1 times this formula is given in the notes, right? For 3 by 3. Then you can use that. Okay. 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 Let me go through the inverse of a matrix. Okay. And do some using some of the methods. And then we'll go through some of the exercises. Okay, so the last time I stopped is determinant. Okay, any question? Ada soalan apa-apa tak? It's okay to ask question. Okay, Eugene?
Prof, if we use the cofactor expansion, right? Like the one on the board, let's say the 3 by 3 matrix, the determinant inside don't have two zeros below one column. Like this one is 5, 5, 2, 1, right, on the whiteboard.
Yeah.
If we do the row operation on this one, the determinant will still be the same.
Yeah. So you do this, right? So this by the first column, right? You will get -1 times, right? Okay, so you get this. Checking, yeah? Checking the other way. Okay, now, then don't forget you have this negative outside. You can, if you don't want to do the add two columns, you can actually do that. But if you want to, if the question is use the cofactor expansion, meaning you have to use it until it's 2 by 2. If the question is use cofactor expansion, row or column to find the determinant. So for the first one is okay because you reduce, okay, like this. And for this one, so you will take, probably you want to take third row, right? Say you want to take third row, we multiply this at the end, yeah? So plus minus plus, right? So you will have 1, cancel, oops, 9054, okay, plus minus plus, plus 3, cancel, 592. Oh, I supposed to put 0, right? Minus 0 times, but it's 0. 1, 1, and then we get 9054. 0 minus 0, nothing. Plus 3, 5925. So this comes out to be 36, right? 36 plus 25 minus 18. 25 minus 18 is 25 minus 18, 7. Times 3. 21. So this is 57, right? So this is negative 57. This part only I calculate here. So you get negative 57. And the same, right? So Eugene was asking if the answer is the same. Yes. And using this, you don't need to do any row operation or fraction. Yeah, you just follow through the cofactor. Okay, and if you use this column, right, you can also get this. We will also get the same answer. Determinant is unique. Okay, this determinant is unique. Somebody asked me why she get the different echelon form, because echelon form is not unique. Okay, your echelon form and your friends might be different, using different operation. Okay, any other question? Okay. Okay tak? Okay. All right. Okay. I think this is the last topic, is it? The inverse. Yeah. The last topic of chapter 1 is on the inverse of a matrix. I will stop today at 12:30 to give you your quiz. Yeah. So you will have 15 minutes to answer your quiz, and then 5 minutes to scan and upload in the e-learning. All right. Inverse of a matrix. You have seen this before, but probably in a smaller dimension, right? So this is section 1.8. Inverse of a matrix. Okay. Now, this can be found, the inverse of a matrix A can be found only for a square matrix. Okay, you cannot find inverse for not a square matrix, m by n. A has to be square. So if A is an n by n matrix, then B is called the inverse of A if A times B is equal to the identity matrix. And the same thing to multiplying on the right or on the left. Okay. We denote D as the inverse A to the -1. That's the inverse. Okay. If A has an inverse, then A is called invertible or non-singular. Okay, so if you are given like show A is invertible, meaning it has an inverse. Show that A is non-singular, meaning it has an inverse. Okay, if it's singular, meaning it has no inverse. A is singular. So these are the terms, right? Okay. Don't forget, this is not only for this class here. You need to know this until at least you are in the final year, because you'll be using this again and again in some other classes, courses. Okay. Now, there is a theorem. Okay, A is invertible. A is invertible if and only if the determinant is not 0. Okay, so you can easily check if given a matrix whether you can find the inverse or not. You can find the determinant. Okay. Give me an example of a singular matrix. Give me an example of a matrix which has no inverse. You can type or you can unmute. Give an example of a singular matrix. Eugene said 2 rows with the same entry. So maybe you want to give something like this. Right? This is what you meant, right? Because if you have 2 rows with the same entry, by the property of the determinant is 0. Because you can actually find the determinant by using elementary row operation, right? Negative row 1 plus row 3, you'll get all 0. And then you can reduce and get 0. Okay, this is one example of singular. Anyone else? Give me an example. Actually, the easiest one is 0 matrix, right? Determinant is 0, is a 0 matrix. There is no inverse because if you said there is an inverse of the 0 matrix, can you find the inverse to get this to be identity? No, right? You cannot find any matrix, multiply this and to get identity. If you think about 0, 0, 0, 0, is it possible to find this for this to be equal to this? It's impossible because whatever you multiply by this is just 0, right? They're all 0. So how can you have this to be equal to this? So this is what you learn at school, right? The 2 by 2 matrix. So this is also singular. The 0 matrix is singular. And even the determinant is 0. Okay. If you look at so many matrices, right? Like this. Very easy. Because there is 1 row of zeros, right? So this is also singular or not invertible. If you don't want to put this, I put 1. This is upper triangular and the determinant is the product of the diagonal and one of the diagonal entry is 0. So when you multiply, still you get the determinant is 0. So if you are given a question, if the question is determine whether the matrix is invertible or not, don't find the inverse yet because you will be probably wasting your time. Check the determinant first. So if the determinant is not 0, then the matrix is invertible. Okay? That's the definition. Okay. Now the next theorem. So first we have that A is invertible if the determinant is not 0. And what is the determinant of the inverse? This is theorem 1 point. Okay, the determinant of the inverse of a matrix A is actually the inverse, or the, in Malay we call salingan, right? The reciprocal, or you can write this as a number, right? You have a number, right? But people don't really write like this because they tend to be confused with what is a number to the -1. So normally we will write like this. Okay, the inverse, the determinant of the inverse is 1 over. So if it's 3, then the inverse has determinant 1 over 3. Okay. Now, how do we prove this? So, how do we prove this? Question would be, show that the determinant is this. Okay, so how do you show? So, proof. Okay, we have A times A inverse is the identity, right? Property of the determinant, I'm supposed to give this first. The determinant of a product of two matrices is the product of the determinant. Okay. So, did I put that anywhere? Supposed to. Okay, so what's the determinant of this? The determinant of A inverse is equal to, because they are equal, right? So their determinant has to be equal also. What's the determinant of A inverse? Using this formula, this is equal to A times A inverse. What's the determinant of I? It's diagonal. What's the determinant of I? 1. Right? So the determinant of A inverse, now it's just a number, yeah? It's just a number, we divide. Since the inverse exists, this is not 0, right? So we can divide. So this is what we want to show. You see that the proof might be very, very simple, but you have to understand how do you prove it is by using the definition and take the determinant and then just use the property. Okay, so after this, if I give you proof that this is equal, you know how to prove it. Okay, let's look at some other properties. What is A inverse inverse? A inverse inverse is A. Okay, you take the inverse, you get A. Okay. Now, first, A has the inverse, right? A has the inverse, so the determinant is not 0. And the inverse has the inverse because the determinant of the inverse is also 1 over something which is not 0, right? So A inverse exists, or A has an inverse, thus determinant A is not 0. Okay. Then A inverse has an inverse. Since the determinant, the inverse of the A inverse and the determinant of this is 1 over the determinant of this. And this is not 0. Okay, so the original is also not 0. Okay. All right. Right like this. The determinant of A inverse, the determinant of A is not 0. So the determinant of A inverse is 1 over determinant of A. This is not 0. So the determinant of A inverse also is not 0. Thus, since the determinant is not 0, thus A inverse has an inverse. Pretty confusing, right? The inverse has an inverse, which is actually the original matrix, but we don't know yet. Okay, what is the inverse of the inverse? Next, we want to say the inverse is actually A. Why? You go back to the B inverse. Oh, sorry. B is A inverse, or A inverse is B, since A times B is B times A is, right? Or A times A inverse is identity. My point is, if you have something like this, something is something inverse, you multiply these two. You multiply these two. You want to see whether it's I or not. Okay? So now, this inverse is A. So we check. A inverse times A, this, right? This is this. Multiply by this is I. Okay, the proof is just straightforward, but it is the proof. So this gives A inverse is A. Because when you multiply A inverse by A, yes, you get I. Right? By this. Okay. And the next one is AB inverse is B inverse A inverse. Given A, B, N by N with inverses A inverse and B inverse. I have to have that statement actually before I write this. Given A, B, N by N matrices with inverses A inverse and B inverse. Okay, so we know determinant of A is not 0, determinant of B is not 0. How do we know that AB has an inverse? Right? So determinant of AB is determinant of AB is determinant A times determinant B. And this is not 0 and this is not 0 because they have inverse. Something not 0 times not 0 is not 0. Okay, so AB has an inverse. Okay, now why they are equal? All right. So actually the inverse, the determinant of the, oh, let me skip that first. Let me show this first. So remember when I said B is A inverse, we want to multiply AB or BA is I. Yeah. So this is something inverse is equal since you take B inverse, A inverse, then you want to multiply by inside, right? AB. How do you multiply this? Okay, associativity, you can change the parentheses, right? You can do like this. When you write, you have to show, you cannot just cross, cross, cross. What is A inverse A? I. Right? And I times B is B, or so. So you multiply this on the left, you get I. You also need to check if you multiply this, because this is BA and AB, yeah? Times on the right. Then you have to show both sides, left and right, is equal to the identity. Since when you multiply is an identity, one is the inverse of the other one. So this inverse is this, or this inverse is this. This is how you can show something is the inverse. Okay. Actually, it's in the notes, but just want you to understand what it meant by that. And the third one is A inverse transpose is A transpose inverse. Meaning you want to take the inverse of the transpose or the transpose of the inverse, you can find first either one, because the transpose of the inverse is the inverse of the transpose. Okay. And you can do the same thing to show why this is true, because you can multiply AT, right, times A inverse T. You see the transpose you can take out, right? Using the formula, AB transpose is B transpose A transpose. Then this is to go back, right? So this is A inverse A transpose. You have to change, right? So this is actually this. So why do I do this? I want to show this is the inverse of this. So you take the inside inverse, AT, times the whole thing, right? Like this. What is A inverse A? I. What is I transpose? Is I. Right? So make sure you get used to showing this using the definition of the inverse. Okay. Now, we want to find the inverse, right? I'm not sure if you have learned this before. To find the inverse of 3 by 3, maybe using the minor cofactor. Probably you have learned that before at school. But first we want to find the inverse using elementary row operation. That's what I said. If you cannot do row operation, you cannot pass the class. You have to master your row operation. All right. So how do you find the inverse? Okay, any question before that? Okay, the steps are given in my notes. Okay, find the inverse. Finding the inverse of a matrix using elementary row operation. So step 1, sometimes you want to check whether determinant is 0 or not. If you don't want it to be 0, because we want to find the inverse. Okay. The second step is to write A and I. And I want you to write dot, dot, dot. Okay, it doesn't have to be 3 dots. You can, but not because you will, if you put like this, you will be confused somehow with your determinant later. Okay, so we use dot, dot, dot. Okay, now the third step, reduce AI using elementary row operation until we get row reduce echelon matrix. Okay, and produce if there is an inverse, you will get the final form of RREM to be this. There will be identity on the left and the inverse is on the right. Okay. Right. So let's try and do this. Okay, I don't want you to write because this is in the notes. I want you to look at the board. Okay, look at the board. We will do one example. The example is in the notes. Okay, so focus on my explanation. All right, so we want to find this matrix A. 2, 3, 4, 2, 1, 1, negative 1, 1, 2. Okay, the question is find the inverse, right? Find the inverse. Now, because the question is not on finding the determinant, you can use any method to find the determinant. Sometimes the question show that the inverse exists. Okay, show that the inverse exists, then find the inverse. That means you have to show the determinant exists by, show the inverse exists and find the inverse. Meaning you have to find the determinant, show it's not equal to 0, that has marks, right? If the question just find the inverse, you don't have to find the determinant first, right? So depending on the question, if the question said, show that the inverse exists, meaning you have to find the determinant, show the determinant is not 0. Yeah, if the question just to find the inverse, should be an inverse, right? So you just using row operation, then you have to go straight ahead. Okay, now you can use any method to find the determinant. In the notes, I said to find along the first row, but you can use any method. Okay, if you really like row operation, you can also make some zeros, right? Then you can just, but the determinant turns out to be -1. Right? One way is to like this, right? And you multiply, yeah? 4 minus 3 plus 8 plus 4 minus 2 minus 12. So this is 1, 9, 13, 11 minus 12 is -1. Or you can use any method. Okay. But we want to see the inverse, Okay. Oh, we need to take a break, right? Right, so we will do this slowly, yeah? I will do this slowly. No writing. focus. Okay, so you do tak semestinya 3 but dot. Yeah. So you write the identity matrix. Okay, then you look at this as the whole matrix 3 by 6, right? Look at it as the whole matrix 3 by 6. You want to reduce, so you want this to be 1. Okay, and try not to do fraction in the very beginning. So don't take 1/2 R1 because you will get fraction, right? Then it's much harder to calculate. So suggestion, jangan tengok, jangan mengelak. You can write in the chat or you can unmute. Suggestion, how do you make this 1? How do you make this 1? Yeah, row 3 plus row 1. Because this is -1 plus 2 is 1. Okay, then you have to do for all, yeah? To do for all. Now, I copy because I don't change row 3, I change row 1 only. So row 2 copy. Common mistake. Student do not copy the right one. Okay, student don't understand their own writing. Like right now, my number is 9. I see somebody realize that, right? And then you copy it wrongly. Okay, now you add row 3 plus row 1, -1 plus 2, add 1 plus 3, add 6, add this one also, yeah? 1, 0, 1. And I will do this again because I want to make sure this is right. So 1, 4, 6, 1, 0, 1. Okay. 0 plus 1 is 1, not 0. Okay, now I can make this and this 0, right? So I will do -2 row 1 plus row 2, row 1 plus row 3. Right? -2 because this is 2. So -2 row 1 plus this. This is the same number already 1. So just add. Then you will get. Okay. Now you don't change row 1. I copy row 1. As usual. Okay, so -2 row 1 plus row 2, -2, 0, -8 plus 1, -7, -12 plus 1, okay, -2 and add, 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 -2 and add. Please raise your hand or unmute if I make a mistake. Okay. Now, row 1 plus row 3 is easy. You just add. So you just add, you get 0, 5, 8, 1, 0, 2. Okay, so row 1 plus row 3. So 0, 5, 8. 0, 5, 8, 1, 0, 2. 1, 0, 2. Okay. 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 Next. This is 7. This is 5. How do you want to make this one? Now, you try not to use fraction. Okay. And to make this one, if you multiply this by 3 and you multiply this by 4, you will get this negative 21 and 20. Then the difference is 1. Okay. If you are okay with fraction, then you can just go ahead multiply by 1/7. But please be very careful. All right. So don't ever use the row before. So let me check what I did here. Oh, this is a little bit different. I changed. Okay. In the notes, I did something a little bit different, but later on, I did multiply by that. Okay, in the notes, I interchange row 1 and row 3. I don't add, but it's okay. Okay. I'll do this first, yeah? If you multiply this by 3, then you multiply this by 4. Okay, you get 21 and then 20. So the difference is 1, as long as the difference is 1. If you multiply larger, you don't get the difference 1. So what I will do is 3 row 2 and 4 row 3. 3 row 2 and 4 row 3. So I will get 1, 4, 6, 1, 0, 1. Okay, and then I get 0, multiply, or I can multiply by negative. So if this is negative, that will be 21, and then this is positive, then later on I just add negative row 3 plus row 2, then I will get 1, right? So I will do negative. So I will get 21, 33, 6, negative 3, 6. All right. And then 0, I multiply by, you can multiply also by negative 4. Or later on, you multiply by negative 1 and add, doesn't matter. So let's try multiply by negative 4. And you see, negative 20, negative 32, negative 4, 0, negative 8. Check again, negative 4, negative 20, negative 32, negative 4, 0, negative 8. Okay. Okay. Now, you want to add. You want to add. I don't need to be negative, but I just want to add without multiplying by anything. So I want to make this to be 1. Yeah, I want to make this to be 1. That's why we go through all this hassle. So later on, we don't get any fraction. Okay, so R3 plus R2, you will get, copy the first row. Okay, and then copy the third row. Okay, and then add. This is 0. This is 1. This is 1. This is 2. Negative 3. Negative 2. The number looks big, but later on it will reduce, yeah? And then you want to make this 0 and this 0. If you change anything before fraction, then it will be harder. But you don't mind fraction, is okay. So I copy the second row. Okay. And then the first one, negative 4, row 2 plus row 1. Get 1, 0, 2. Negative 4, row 2 plus row 1. Negative 8 plus 1. 12 plus 1. 8 plus 1. Okay. And then 20. Row 2 plus row 3. Okay, so 0, 20 plus 20 plus, okay, 20, 40 minus 4, 36. 20 minus 60 and negative 48, right? Oh, this is really nice because this is all multiple of 12. Okay, so you don't get to get any fraction anyhow. So, alamak, tak muat pula dah. Okay, I go back to here, yeah? Okay. So, just negative 1 over 12, row 3. So, I will get 1, 0, 2, negative 7, 12, 9, 0, 1, 1. Copy, copy. Kopi, bukannya kena minum kopi. Nisa suruh minum kopi. Pandai je. Okay, 0, 0, 1, 0, 0, 1, negative 3. Bagi 12 kan? Bagi 12. Bagi negative 12. 1, negative 3, 5, right? 5. And then?
Negative 4.
Mana ada negative 4?
Oh, 4. Salah.
Dah bersemangat dah. Sampai salah. Okay. Betul. Okay. Now only one more. Just one more. Last one. Then we will get the answer. Okay. All right. So this one, you have to make this and this 0. Right? So negative 2 row 3 plus row 1. Negative row 3 plus row 2. This, negative 2 row 3 plus this. You will get this to be 0. Negative row 3 plus row 2. Then you will get that to be 0. Right? So you don't change row 3. So 0, 0, 1. Negative 3, 5, 4. Okay, so negative 2 row 3 plus row 1, 1, 0, 0. Okay, so for this one, negative 2 plus, yeah, negative 2 plus, negative 2 plus, negative 2, negative 10 plus, negative 8 plus. Then this has to be 0, 1, 0. Then just negative and add. So you get 5, negative 8, negative 6. Okay, so the operation is not unique, right? The operation is not unique. Muka tak masuk dalam screen. Because you can do any other way, right? Terpadam, tapi maybe you can try if you want to see. It's not easy if you have fraction. Kata nak shortcut kan, you just multiply by -1/7. And then this is all over 7. And then you want to multiply and then you want to add, can easily make mistake. Okay. How do we know that the answer is right? Check pakai calculator. But you won't get the marks if you check in your calculator. I cannot see. Yeah? If the question is check your answer. Okay, then you will take the inverse. So when you finish, you will write. So A inverse is -1, 2, 1, 5, -8, -6, -3, 5, 4. This is your answer. -1, 2, 1, 5, -8, -6, -3, 5, 4. Now, if you are asked to check, then you need to check. And by multiplying A by A inverse. Left or right is the same because if it's the inverse, is unique, right? So, alamak. Mana matrix original dia? 2, 3, 4, 2, 1, 1, -1, 1, 2, multiplied by -1, 2, 1, 5, -8, -6, -3, 5, 4. Okay, so you have to multiply equal. And it has to be equal to identity. Okay, so try -2, 15, 13, 13 minus 12, 1. Oh, lega, dapat 1 kan? Ada suspend. Then you check again. 4, -24, 4, -20 plus 20, 0. Selamat. 2, -18, -16 plus is okay. And then you will go, okay. Boleh ke macam tu? You have to check. Right? You have to check every single one until you get it right. Because I found many times the student actually did not get the right answer. Whether the student is too confident or the student knows you didn't get the right answer, but really want it to be identity, then you just write the identity. Okay, so this is actually the right answer. So this is the check one. Yeah, this is the check one. Okay, now there is an exercise in the soft copy that I put in the e-learning, but the answer is already in the notes. Oh, did you get the notes by post? Dah ke belum? Macam tak ada siapa yang jawab. Dapat ke tak dapat? Saya pun lupa nak tanya. Dapat best kan? Dapat yang do not copy ke apa ke, it's copyrighted, right? And don't jual balik ke apa, simpan. It's a treasure tau. Nanti adik-adik yang junior nak ni, nak belilah apa, simpan. Alright, it's actually priceless. Saya masih simpan tahu nota saya daripada undergraduate. Student ni nota pun tak tahu kat mana dah. Okay, I will stop this for today because we have a quiz. And in 1 minute, yeah. And you don't have to be on in Zoom for the quiz. But I want to take one group photo for the proof before the quiz. Okay, turn on your video. Okay, cepat sikit. Okay. Alright, okay. Reaction. Sekejap. Background banyak nak kena ubah ni. Virtual background. Okay. Reaction. Okay. 1, 2, smile, camera. Gitu. Okay, page 2. Sekali lagi awak tak tahu awak kat page mana, senyum aja, nak peace, nak apa. Oh, reaction. 1, 2, 3. Okay, last page. Reaction, tukar. Biru. Okay, 1, 2, 3. Ada yang tak letak reaction. Okay. Okay, guys, you can access your e-learning. Let me share first the question. Hana boleh tolong saya share tak? Jangan keluar dulu. Dah keluar Zoom pula dah nanti. Kejap. Saya baca soalan. It's okay, don't worry. 1 minit je. Okay, so you can find the question from the e-learning. Print pun tak simpan kot. You can just write your name, IC number in a piece of paper and copy this question. So the first question given A, by definition, determine whether A is Q-symmetric matrix or not. It's okay, it's open book. No Googling, no discussion as usual, yeah? Just it's an open notes. The second question for this matrix, list all sub-matrices of B with order 2 by 3. Okay, and the second question, given A, Aij, B, Bij with dimension M by N, C also, show that A plus B transpose is A transpose plus B transpose using the one given. Okay, do not give a specific example. You have to show in general. Okay, this will give you 10 marks. All the best, guys. See you again. Ni hari apa? Selasa ya? Oh, next week, Sunday. Okay, you have 15 minutes and then 5 minutes to upload. All right. All the best. Bye.